Hello.
Hello again, we're now on to question 6 of our Core 1 paper.
Yep.
Excitement is very high in the studio.
This is a big marker, 18 marks altogether for this question.
Yep, so we've got polynomials and integration coming up, so fasten your seatbelts.
Yeah. So, in the information in the question, for the first part it gives you this, and for the second part it gives you that, so we've just put them both up for you. That's a polynomial it's told you, and that's what it looks like.
Yeah, we have our 3 points that goes through the axes, but we don't actually know what A is yet.
Yep.
So, A part 1, it says use the factor theorem to show that x plus 1 is a factor. And this is covered in one of our videos, so we'll do it quite quickly here.
Yep, so if x plus 1 is a factor,
then you put minus 1 into it. So P of minus 1, you won't lose any marks, and if your working's wrong because you've done the right sort of thing.
so you've got minus 1 cubed is just minus 1.
It is.
Remember, if you cube it, it goes back to being minus.
And then minus 7 becomes plus 7, and then we have minus 6, and that is equal to 0, which means it has to be a factor. And you can show this by saying, therefore, with your weird sideways smiley face, it is a factor.
Yep. This implies, or therefore, ... like that would also be accepted. Either way.
So now we've done part A, part 1. Then we do part 2, which is express the polynomials as linear factors. So that sounds a little bit crazy, but now we have our x plus 1, we can divide the entire polynomial by that to find the next linear factors.
So, x plus 1.
So we put it in our weird funky bus stop.
X cubed minus 7x minus 6, which is our polynomial that we're dividing.
It is. So what we want to do is we want to create the middle bit each time.
Yeah. So, what do you have to times x by to get x cubed?
Yeah, so we x squared. So then we put that at the bottom.
Yep, so we times both of these by these things. So you've got x cubed, and then you've got x squared times 1, which is plus x squared.
And we minus it from what we've got here, but the thing is to look out for is we haven't actually got any x squared, so it could be said we have 0 x squared. Sometimes it's easier to put that in, so you don't make the mistake of then putting your 7x in.
So I'll do that just for the sake of making it simpler to see what we're doing. So it's naturally plus 0x squared, as Triv said. Then you're minus 7x minus 6.
Yeah.
Remember, putting it in depreciative order form. So you minus the things.
Yeah.
X cubed minus x cubed is nothing.
And then you minus it from 0, so you have minus x squared.
And that's your first step.
Now you want to create minus x squared. So to get that you need minus x, and then you just times that again. So minus x squared, out there will cancel, then minus x. You actually have a 7, so minus is a part plus, it becomes 6x.
Minus
6x, sorry.
And you've got to times that by minus 6 to get that. So just to check, minus 6x minus 6 should come to 0 if you've done it right, which it does. So that's great news.
And that means that those are your linear factors. But at the moment we've only got one linear factor and a quadratic. To sort this we need to factorise our quadratic. So if x plus 1, if we factorise this, it will be x minus 3 and x plus 2.
Plus 2 and x minus 3.
Yep. And there are 3 linear factors. Sorted.
So that's part A, and that's already been 5 marks, but part B is a hefty thing, which is fairly common in a Core 1 paper.
It is, near the end. Polynomials and integration are often linked like this. So part 1 is state the coordinates of the point A. We actually have got enough to do this. Our linear factors show where it cuts the axis.
Just like with a quadratic when you get your 2 brackets. It's the same with this, except there's 3 points.
Yeah, at A is a point where it cuts the axis. We know what we already have. We have our minus 1, so that's our positive one, whenever you swap them.
Yep. So our minus 3 must therefore be our 3.
Yep.
So the only one left is plus 2, which is minus 2.
So
and if you look at your graph, that's going to be at least about right, so you can suggest you got it right.
You can estimate what you think it should be.
Be careful, it wants it as a coordinate, it doesn't just want what x equals, so
minus 2 is the x-point, and it says it's cut the x-axis, y is 0.
There you go.
So now I've done part 1, that's the easy bit. Now we have the big integration part. So it says integrate, or find, by integral 3 minus 1 of your polynomial. So the first step here is integrating it, which is quite mean, and it's already started with cubes. We're going to have lots of to the 4s in that.
Or indeed. So when you integrate this, we're going to get a quarter x to the 4.
Yeah, because we increase the power by 1 and divide by the new power.
So quarter x to the 4 minus, and then you'll do the same thing here, it's 7 over 2x squared minus, and there's an actual x to the 0 here, so you can increase the power, so just minus 6x and plus c.
Yeah.
Now you can do the square bracket thing where you minus 1 from the other, as you're familiar with.
Yeah. So start with, you put all of the 3's in place of x's, so we have a quarter of 3 to the 4 Now these numbers are going to get quite big, so make sure you do your calculation carefully because it's where errors might come. And then you just put it into the rest of them and you minus it from the other bits. The rest of them.
3. So then what Triv's going to be doing in the second bracket is the same thing, but where there's an x, there's now a minus 1 instead of a 3. What I'm going to do is I'm going to do this. 3 to the 4 is 81, so that's 81 over 4, minus 3 squared is 9, times 7 is 63 over 2. A quarter, a sort of quarter minus a sort of half is going to be awkward. So I'm going to convert the halves into quarters, so you just double up both. So that's 14 over 4, that's the same as 7 over 2. So now they'll be easier to minus because of the same denominator. So now I can do it. 14 times 9 is 120, oh bloody hell, there we go. 126 over 4.
It is
Minus
often,
6 times 3 is 18.
Okay, it's quite hefty.
Now 18 is the same as 72 over 4, so then you can minus them all together. So, get ready for that.
Does get quite complicated. All your minuses, you should be careful with your minuses. When you square a minus, you get a positive, and you cube it, you get a minus again, because it's minus times a minus times a minus. And be careful of your minuses. Here I have minus 6, minus times minus 1, should be positive 6. Yeah, be careful of that sort of thing.
So minus 117 over 4, that's this bracket altogether.
And this bracket altogether is 15 over 4 minus 14 over 4, which is 25 over 4, sorry, minus 14 over 4.
117 over 4, what is that exact?
21, 11 over 4. Yeah, that's my half.
Okay, so I've got 29 and a quarter minus another 2 and 3/4
Yeah.
is minus 32 altogether.
So that was awkward because of the quarters, but other than that, reasonably simple. So when you look at that and you might go, wait, integration's an area and you've got minus 32, have no fear, that is fine. As it is under the x-axis, you will get a negative value just because of the negative sides.
When that happens, commonly the next question, which it is in this case,
Yeah, is
to say what is the area then?
yeah, so the area, you can't have a negative area, that is true.
Yeah.
So then the area instead just becomes the positive version of this.
So it's 32. It was expressed minus 32 because it's under. So there you go. Now you know.
Yep, and now we have a differentiation question. So
Yep.
let's find the gradient of the curve, which we know at point B. So we know what point B is, so we can do that bit in a minute.
The trick of this question is it says find the gradient of the curve. It doesn't tell you to differentiate. To find the gradient of a curve, you have to differentiate.
Yeah.
That's the thing to notice.
It is, so now we should get on with that. So
dy by dx.
So it's good to write down what you are doing so you get marks even if you make a mess up arithmetically, which is most common in core 1 because it's a non-calculated paper.
So I'm differentiating that. You're going to times the coefficient by the power and reduce the power by 1.
Yep, so we're going to have 3x squared minus 7, and the 6 will disappear because you're timesing by 0.
But that's not all the question. Triv just said you've got to do it at the point B.
We know what point B is, it is minus 1, 0, so we put our minus 1 into our equation on our place of x, so it becomes
minus 7,
yeah,
which is
minus 4. So that will be our gradient at point B.
Which looks about right because you can see it's decreasing.
Yeah, and you can sort of think about it like that. Then it says, part 5, it's quite a hefty question, hence find an equation to the normal of the curve at point B. Now this is remembering your linear graph things. So a normal to a tangent is perpendicular, so it will have an inverse gradient.
Which in this case, the inverse gradient of minus a quarter,
Minus
minus 4 is
a
a quarter. So
Yeah.
that's our m of this normal.
And we have our y and x values.
X equals minus 1 still because it's at the same
Yep,
point.
and y equals 0 here. So using y equals mx plus c, we can then find out what c is.
Yep, so substitute all the values in.
So 0
equals
minus 1, lots of quarter, so there's a minus a quarter there, plus c. So c must equal a quarter, which gives us our equation of y equals quarter x plus a quarter. And that is the equation of our normal.
And there you go.
That's the end
18 marks of your
question
paper.
6, which
Massively significant.
is rather huge, but
About 20% there.
yeah, as long as you keep a clear head, you'll be fine.
So we're going to go on to question 7, which is the final one in this whopper of the paper.
Absolutely.
We'll see you there.
Alright.